Welcome back. In this lecture, let's talk a bit about units and unit conversions and all the hard stuff that we have to learn. All right, let's first talk about units. In psychology and sociology, those are called the soft sciences because you really can't put numbers on anything. What do I mean by that? Well, in psychology, you can't say Igor is 12.4 crazy and Ludmilla is 8.2 crazy. There's no number for crazy. They're crazy, but there's no number for it. In the hard sciences, physics, chemistry, mathematics, we need to put numbers. We need to say how big or how small something is or how much of something we have. Okay? Now, in the United States, or more specifically here in Brooklyn, what do we measure distance in? Well, there's a bunch of units we can use for distance. Everybody knows about inches and feet and yards and miles. Oh, like great units. Oh, they're so fantastic. Well, let's look at it. We know that a 1 foot, right? 2 dots, 1 foot, 1 dot, 1 line, is equal to 12 inches. Everybody should be familiar with that. 1 yard is 3 feet, right? Or 36 inches. Fantastic. 1 mile, oh crap. How many feet are in a mile? Nobody knows that, but I'll tell you. 5,280 feet are in a mile. Now suppose, just suppose, I ask you, approximately, listen to my words, approximately, how many inches are in a mile? Well, it's easy. There's 5,000 feet in a mile. Each foot has 12 inches. So what do? You multiply 5,280 by 12. I said approximate. So 12 times 5 is about 60,000. I'm just going to put about 60,000 inches. Okay? Really, if it's a multiple choice question, you don't have to work it out. You know it's not going to be 60,000, but it'll be a little more than 60 because there's 5,280 feet. So 64, 65, who knows, but it's about 60,000 inches. For a multiple choice exam, well, for the TEAS exam, just knowing these facts, you can put the answer right away. You do not need a calculator and calculate to the nearest decimal. Okay? Now, let's look at these numbers. 12, 3, 36, 52, 80, 60, ridiculous numbers. That's why the rest of the world uses the metric system. So let's go metric. Okay? The metric system, again, is based on powers of 10. Very logical. Okay? So let's talk about distance for a second. One of the conversions the textbook gives, the simplest one, is inches and centimeters. 1 inch is equal to 2.54 centimeters. What is a centimeter? Well, centi means hundredth. It's like if you have 10 cents. 10 cents. What is a cent? It's 100th of a dollar. Okay, so centi is going to be 100. Remember what hundredth was in scientific notation? 10 to the minus 2. Okay, we'll come back to this. I want to talk about this conversion for 1 second. For almost everything we'll do in this class, for now, is we're going to approximate this as 1 inch is about 2.5 centimeters. 2.5 centimeters. Why am I doing this? So we can do things in our head, so we can connect neurons, so we can figure things out quickly. Okay? 2.5. So, quick problem. Suppose I say 60 inches is how many centimeters? Okay? Well, we know that 1 inch is 2.5, or approximating, centimeters. So if I do 60 inches, that means I have to do 60 times 2.5 centimeters. You see, in an equation, you have to do on one side, you have to do the other. If I multiply this side by 60, I multiply this side by 60. Fantastic. So let's do this in our head. 60 times 2 120. 60 times a half is 30. So 120 plus 30 is 150. Another, let's do 70 inches. Well, we need 70 times 2.5 centimeters. Remember, we're approximating. We're not using 2.54. Once again, same logic. 2 times 70, 140. What is half of 70? 35. 140 plus 35 is what? I think 175. Oh, we're feeling smart now. One more. Okay. 90 inches, sorry, is what? 90 times 2.5 centimeters. 90 times 2, what? 180. Half of 90 is 45. 180 plus 45 should be 225 centimeters. Okay? These are the kind of calculations, things I want you to learn to do in your head. Because when you take the TEAS exam, taking time on the calculator just takes precious seconds away, and you don't have precious seconds. You must act, or you must work as quickly as you can. Okay? Now, when you practice problems, as I said in class, getting the correct answer is really not that important, especially if it's a multiple choice. Try to do it in your head as quickly as possible. Try to train yourself to do it as quickly as possible. Okay? Again, time is the biggest killer for the TEAS. Now, I want to show you what we did in class. Do this number line. Okay? But before that, let's talk about, we'll do distance as our example. Okay? We're going to look at prefixes, and these prefixes you must learn. I wish there was a way out of it, but you must learn it. The prefix kilo, again, no jokes about drug dealers, but most of you know what a kilo is. It means 1,000. In scientific notation, it means 10 to the third. Okay? Centi, like cents, is going to mean hundred. Hundredth, TH, 1/100. Okay? Milli is 1,000th, 10 to the minus 3. Okay? Now, micro is 10 to the minus 6. Micro refers to millionth. Okay? And then finally, a word everybody knows today with technology, nano is 10 to the minus 9. This is a billionth. So here, I'm just going to write millionth, that TH ending. And here, I'm going to write billionth. Okay? So we have 10 to the plus 3, 10 to the minus 2, 10 to the minus 3, 10 to the minus 6, and 10 to the minus 9. Keep those numbers in mind, because now I'm going to do that little conversion chart that we find so useful. Now, once again, I want to emphasize, this is very, very important. When you do conversions of units, I'm going to show you a method. I really don't care what method you use. Do anything that works. Okay? If you always get the correct answer with your method, then use your method. Do not worry about how I do it or how anybody else does it. Okay? Just do not, if you can, violate any laws of algebra, the Torah, the Quran, anything, just make sure it's correct. So let's give this a try. So we had the numbers plus 3, minus 2, minus 3, minus 6, minus 9. I'm just going to write a number line here. I'm going to put a 0, plus 3, minus 2, minus 3, minus 6, and minus 9. Now, what do these refer to? These really refer to 10 to the third for kilo. 10 to the 0, 1. 10 to the minus 2, centi. 10 to the minus 3, milli. 10 to the minus 6, micro. 10 to the minus 9, nano. Okay? Let's do distance. So we're going to have kilometers, centimeters, millimeters, micrometers or micrometers, and nanometers. Okay? So I'm going to do a simple question. Okay? First question is going to be 1 kilometer is how many micrometers? Now, look at the symbol I wrote. Mu, this is the Greek letter mu, so I'm going to write this funny looking U, is pronounced mu. It's the Greek letter mu. So this is micrometer, or micrometers, which refers to 10 to the minus 6. Okay? So 1 kilometer is how many micrometers? Does everybody see that micrometer is much smaller than a kilometer? Whenever the object on this side of this type of equation is smaller, the exponent is going to be positive. Let me say this again. Smaller, the exponent is positive. As we said in class, this is contrary to everything we learned, right? When it's smaller, it's usually a negative thing. But for us, when it's smaller, the exponent is going to be positive. We'll see the reverse later. So let's look. How do we do this? Well, we find micro on our table. We said it was micro, or micrometer was minus 6. Kilo, remember? Kilo, drug dealer's kilo, was plus 3. What do we have to do? We count the steps from minus 6 to plus 3. There's 6 steps to get to 0, another 3 steps to get to kilo, and the total number of steps between micro and kilo is 9. So the number that goes here is plus 9. 1 kilometer is 1 billion, or 10 to the 9th, micrometers. Okay? Let's go the other way. Let's do this. 1 nanometer is how many kilometers? Oh my goodness. So now look what we have. Something small is a fraction of something really, really large. So kilometer is much larger than nanometer. When this is larger than that, remember it's contrary to what we learned, the bigger it is, the more negative the exponent. Bigger, we put a negative exponent. Now what do? We count the steps between nano and kilo. Nano is here, minus 9. Kilo is plus 3. We have 9 steps to 0, plus another 3 is a total of 12. So there's 12 steps. So this answer would be 10 to the minus 12. Oh, how easy is that? Okay, let's do a couple more practices. Okay, very good. I'll keep the table, the chart up. One centimeter is how many nanometers, okay? 1 millimeter is how many micrometers? 1 kilometer is how many millimeters? Okay? So we're going to try to do this. Give you a second. Pause it, see if you get the answer, and then hopefully we'll get the right answer together. Okay? Let's see. Nano is smaller than centi. We agree? When it's smaller, that's a positive thing. Positive thing. Nano, minus 9. Centi, minus 2. Can everybody see the difference between minus 2 and minus 9 is 7 places? So 1 centimeter is 10 to the 7th, or 10 million nanometers. Not bad. Next one. 1 millimeter is how many micrometers? A micrometer is 10 to the minus 6. A millimeter is 10 to the minus 3. Micrometer is smaller than millimeter. So smaller means what? Positive. Remember, smaller is positive. Micrometer minus 6, millimeter minus 3, it's just 3 steps between negative 6 and negative 3. Finally, the last one of these examples, kilometer, millimeter. Millimeter is smaller, excuse me, than a kilometer. Once again, we have a positive number. Excuse me. Millimeter is minus 3, kilometer is plus 3, 6 steps. So there's 1 million millimeters in 1 kilometer. All right, let's get a little harder. Let's do 2 dimensions. 2 dimensions measures an area. So if you have something that's 2 centimeters by 3 centimeters, we would say the area is 2 centimeters times 3 centimeters is 6 centimeters squared. Does everybody see the square? Squared means area. Squared second power. So let's see if we can do something right now. 1 meter squared is how many millimeters squared? Okay? I'm going to go through this very slowly. Okay? Everybody look over here. 1 meter is 10 to the 3rd millimeters. There's 1,000 millimeters in 1 meter. So what is 1 meter squared? 1 meter squared is 1 meter times 1 meter. We're good? But that is 1,000 millimeters times 1,000 millimeters. Now we go back to scientific notation and we simply add the exponents. And so the total is 10 to the 6th millimeters squared. 1 meter squared. It's good? 10 to the 6th. Let's do another one. One nanometer squared is how many kilometers squared? Oh my goodness. Let's look. Back to our table. 1 nanometer is how many kilometers? Well, nano, first of all, this is larger than that. When that's larger than that, remember, larger, it's negative. Kilo is 3. Nano is what? 9. So the difference is 12. 1 nanometer is 10 to the minus 12 kilometer. What about a nanometer squared? Well, that's 1 nanometer times 1 nanometer. And so we get 10 to the minus 12 kilometer times 10 to the minus 12 kilometers. Once again, we use our law for exponents of powers of 10. Minus 12, we get 10 to the minus 24 kilometers squared. Remember, it's an area, is 1 nanometer squared. Wow. Okay. So here we would put 10 to the minus 24. Okay, let's do 3 dimensions. 3 dimensions would be a volume, a length times a width times a height. So you have the units of meters or centimeters or kilometers or nanometers. To the 3rd power, it would be cubed. So let's do one of these. 1 centimeter cubed is how many? Again, I'll go with nanometers cubed. Okay, that's our question. Cube power. So let's review. 1 centimeter is how many nanometers? Well, nano is smaller than centi. Smaller, positive. Remember, if it's smaller, you get a positive power. Nano is what? Minus 9. Centi is minus 2. So this is 10 to the 7th. We might have done that before. So 1 centimeter cubed is simply this. 1 centimeter cubed is 1 centimeter times 1 centimeter times 1 centimeter. And what do we get? We get 10 to the 7th nanometers times 10 to the 7th nanometers times 10 to the 7th nanometers, right? So we add the exponents again. We don't multiply. This is an error people make. 7 plus 7 plus 7 is 10 to the 21 nanometers cubed. Okay? So this would be 10 to the 21 nanometers cubed. Fantastic. All right, that's enough. Go have a drink, and we'll see what we do in the next lecture.